Okay, here we go with calculus the next day, calling it day 13. We're going to do some more U substitution, but today we're going to use the definite integral. Last class, we did the indefinite integral where we're always adding a plus c at the end when we take the antiderivative. This time we're going to do this definite integral, and the definite integral is when you're plugging in your upper and lower limits because you're going to see numbers on that integral sign on the top and bottom. And remember, it's always upper minus lower. So I'm going to keep it similar to what I did last class. So I have this antiderivative I have to take, which is a little bit complicated, but I make my 3x to the fifth minus 2 as my u, and now I have my du is equal to 15x squared dx. And I'm like, oh, well, that's really nice because now I can rewrite this integral as it's still from 0 through 1, but the 15x squared dx, oh, I'm sorry, 15x to the fourth, that's my bad, becomes the du and becomes u cubed du. Okay, we just have to roll with my mistakes. I did fix it. I did change it to 15x to the fourth dx, and now I have the integral from 0 to 1 of u cubed du. And we did this last class, and we said this was 1/4 u to the fourth, and then we put down plus c. That was for the indefinite integral. This is the definite integral, so we're going to evaluate it from 0 through 1. So now I have to rewrite it as equals 1/4 3x to the fifth minus 2 to the fourth minus 1/4 3x to the fifth minus 2 to the fourth. Man, I'm just messing up. Okay. Plugging in 0 and 1. That's putting the u. I got rid of the u and put it in here. So when I do this, I got to plug in my upper and my lower. Okay, so I plugged in my upper and my lower of 1 and 0, and now I need to evaluate. So as you can see, I finished out the problem. I plugged in my 1 and 0 for my upper and my lower, and when I plugged in 1, I got 3 minus 2, which is 1 to the fourth, and I plugged in 0, I got negative 2 to the fourth, and I got 1/4 minus 4, or negative 15 over 4. So this next problem I put out here because I saw some of you had a problem when I had something in the denominator. You always thought the antiderivative of something in the denominator was ln. That's only if it's 1 over x or 1 over u, not when I have something raised to a power. So I set up my u, which is right here, and I really wanted 2x squared, so I had to multiply by du by a third, and now I can rewrite this problem with a u as color 1 over 2, and that's going to be 1/3 u to the negative 4 du. And when I take this antiderivative, well, I better make this u to the negative 3. The reciprocal of that is negative 1/3 times negative 1 times 1/3 is going to be negative 1/9. I'm plugging in my upper and my lower 1 and 2. So I went back in and I plugged in my u. So I made it negative 1/9 of the quantity 2x cubed minus 1 raised to the negative 3, evaluating from 1 to 2. But something raised to the negative 3 is really in the denominator. So I rewrote it as negative 1 over 9 times that whole quantity raised to the third, plugging in 1 and 2. And then I plugged in my upper and my lower. And now I'm going to evaluate. This is just using the calculator. So I plugged those numbers in my calculator, and I got some ugly fractions. I'm not saying this was easy, but I had a calculator do the hard work for me. and I got this weird decimal number of 0.111078. Or better yet, the fraction 3374 over 30,375. So problem number 3, I rewrote it as 3x cubed plus 1 to the 1/2, and then 18x squared dx, and I did my whole u substitution, and I'm able to rewrite the whole integral as 1 over 2, the integral from 1 to 2, 2u to the 1/2 du. Well, the antiderivative of u to the 1/2 is u to the 3/2. Reciprocal of that is 2/3 times 2. This is 4/3. And I'm evaluating from 1 to 2. So after I rewrote it with u, I got rid of the u and rewrote it as 4/3 quantity 3x cubed plus 1 raised to the 3/2, plugging in 1 and 2 as my limits. And you can see I plugged them in. I did upper minus lower, and I get 4/3, and this turns out to be 25 to the 3/2 minus 4/3 times 4 to the 3/2, which equals 4/3 times 125 minus 4/3 times 8. And I'm going to change colors here, which equals 500 over 3 minus 32 over 3, which is 468 over 3, which is exactly 156. So all that messy stuff turns out to be exactly 156. I see there's a lot of work. So on the next page, we're going to talk about how can I redo this with this less grungy arithmetic. And that's what we're going to do next. Okay, so this idea of changing limits is that I don't want to do a u substitution and I had to sub it back out and plug in more numbers and do this and that. It seems like a lot of work. There is a shorter way. And the shorter way is we're going to keep everything as u's and change these limits on top and bottom based on what u is. And it's still going to be upper minus lower, except now I have a quicker way to get to my numerical solution. Okay, these 3 problems on the back are exactly the same as on the front, except we're going to do it in a way that takes less work. Same u, 3x to the 5th minus 2, same du, 15x to the 4th dx. So I can rewrite this as the integral of u to the 3rd du, except I want to change my limits. I don't want to use 0 and 1 any longer. I want to figure out what they are. So what I have to do is plug 0 and 1 into the u equation. So u of 1 turns out to be 3, 1 to the 5th minus 2. So if u of 1 is still 1, it just happens to be that it is the same upper limit. So now when I do u of 0, I plug it in, and u of 0 is equal to negative 2, and that is the lower limit. Yes, obviously negative 2 is going to be harder to plug in than 0, but I'm going to save a lot of time because I don't have to get rid of that u later. Remember, this antiderivative is 1/4 u to the 4th, plugging in negative 2 and 1, and now when I plug in, I don't have to get rid of the u because these limits are based on u. It's going to be 1/4, 1 to the 4th, minus 1/4, negative 2 to the 4th, which I get 1/4 plus 4, negative 1/4. Oh no. Excuse me. 1/4 minus 4, which turns into negative 15 over 4. Again, I did my upper minus my lower. This is my upper minus my lower. I got the same result as what I did on number 1, but I had to do a lot less substituting back and forth and calculating and this and that. Changing your limits saves you, I would say, 2 or 3 steps. So I set up this problem exactly like I did before with my u substitution, And it is going to be the same. It's still going to be 1/3 u to the negative 4 du. That is not going to change. What I'm changing is the limits on the integral. Instead of being from 1 to 2, I plug those numbers into the u, and my upper limit is 15, and my lower limit is 1. It happened to be the same. And now when I take this antiderivative, it's still negative 1/9 u to the negative 3. But now I'm plugging in 1 and 15 for u instead of rewriting it in terms of x and having to do all those calculations and so on and so forth. Using this resetting the limits helps out a lot when I'm plugging in the numbers because I have a lot less calculations. Yes, I'm still going to get this ugly fraction as I did before, but now all I have to do is negative 1 over 9u cubed, and all I have to do is plug in 15 and 1. I don't have to figure out all that other stuff and this and that. And yes, it's an ugly fraction, but it turns out to be the same. Okay, again, I started this problem exactly like I did before by doing my u substitution, and I can rewrite this as the integral of 2u to the 1/2 du. That hasn't changed. What has changed is my limits. Instead of 1 to 2, I plug in 1 and 2 into my u equation. Now my limits are 4 and 25. What's really nice is now that when I take its antiderivative, well, it's still going to be u to the 3/2, so it's going to be 4/3. And I could plug in 4 and 25, and when I plug in my upper and lower, it's going to be 4/3 of 25 to the 3/2 minus 4/3 or 4 to the 3/2. That is plugging in my upper minus my lower. And I get 4/3 times 125 minus 4/3 times 8. And I think you're going to see you get exactly what you had before of 468 over 3 or 156. This is exactly the same as what we did for number 3, except this whole resetting the limits based on u, I think saved me probably an extra 2 or 3 minutes. Okay, thank you very much for watching this video.